Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
You're developing the incident response plan for your company. You need to define the access strategy that your DevOps team will use when reviewing and investigating a deployment issue in your Google Cloud environment. There are two main requirements. Least privilege access must be enforced at all times. DevOps team must be able to access the required resources only during the deployment issue. How should you grant access while following Google recommended best practices? The options are: Option A, assign the project viewer identity and access management (IAM) role to the DevOps team. Option B, create a custom IAM role with limited list/view permissions and assign it to the DevOps team. Option C, create a service account and grant it the project owner IAM role. Give the service account user role on this service account to the DevOps team. Option D, create a service account and grant it limited list/view permissions. Give the service account user role on this service account to the DevOps team.
To arrive at the correct answer, we focus on the keywords: least privilege access must be enforced at all times, access the required resources only during the deployment issue.
The correct answer is option B. Create a custom IAM role with limited list/view permissions, and assign it to the DevOps team.
Why is this correct? B. Creating a custom IAM role with limited list/view permissions strictly adheres to the principle of least privilege, providing exactly the minimum permissions needed for the investigation. Why are the others incorrect? A. The project viewer role is a broad basic role that grants read access to almost all resources, violating the strict least privilege requirement. C. Granting the project owner role provides full administrative access to all resources, which severely violates the principle of least privilege. D. Using service account impersonation for human incident response adds unnecessary complexity and obscures individual user audit logs compared to directly assigning a custom role.
Your company is using Cloud Dataproc for its Spark and Hadoop jobs. You want to be able to create, rotate, and destroy symmetric encryption keys used for the persistent disks used by Cloud Dataproc. Keys can be stored in the cloud. What should you do? The options are: Option A, use the Cloud Key Management Service to manage the Data Encryption Key (DEK). Option B, use the Cloud Key Management Service to manage the Key Encryption Key (KEK). Option C, use customer-supplied encryption keys to manage the Data Encryption Key (DEK). Option D, use customer-supplied encryption keys to manage the Key Encryption Key (KEK).
To arrive at the correct answer, we focus on the keywords: Cloud Dataproc, create, rotate, and destroy symmetric encryption keys. Keys can be stored in the cloud.
The correct answer is option B. Use the Cloud Key Management Service to manage the Key Encryption Key (KEK).
Why is this correct? B. Cloud KMS is used to manage key encryption keys (KEKs) in the cloud. Google Cloud automatically manages the data encryption keys (DKs), which are then wrapped by the KEKs that you create and manage in Cloud KMS. Why are the others incorrect? A. Cloud KMS manages key encryption keys, KEKs, not data encryption keys, DEKs. Google Cloud handles the generation and management of DEKs natively. C. Customer-supplied encryption keys, CSEK, are used when storing keys on premises, not in the cloud. Additionally, users manage KEKs, not DEKs. D. Customer-supplied encryption keys, CSEK, are for keys stored outside of Google Cloud. The question specifies that keys can be stored in the cloud, making Cloud KMS the appropriate service.
An organization adopts Google Cloud Platform, GCP, for application hosting services and needs guidance on setting up password requirements for their cloud identity account. The organization has a password policy requirement that corporate employee passwords must have a minimum number of characters. Which cloud identity password guidelines can the organization use to inform their new requirements? The options are: Option A, set the minimum length for passwords to be 8 characters. Option B, set the minimum length for passwords to be 10 characters. Option C, set the minimum length for passwords to be 12 characters. Option D, set the minimum length for passwords to be 6 characters.
To arrive at the correct answer, we focus on the keywords, password requirements, cloud identity account, minimum number of characters, cloud identity password guidelines.
The correct answer is option A, set the minimum length for passwords to be 8 characters.
Why is this correct? A. The minimum password length allowed by Google Cloud Identity and Google Workspace is 8 characters. Administrators cannot configure a minimum password length lower than this baseline threshold. Why are the others incorrect? B. While 10 characters can be configured as a stricter custom policy, the baseline minimum required by Cloud Identity Guidelines is 8 characters. C. Although 12 characters represents a highly secure practice, Cloud Identity's foundational minimum password length requirement is 8 characters. D. Cloud Identity does not permit setting a minimum password length as low as 6 characters. The platform strictly enforces an absolute minimum of 8 characters.
Your company's Chief Information Security Officer, CISO, creates a requirement that business data must be stored in specific locations due to regulatory requirements that affect the company's global expansion plans. After working on the details to implement this requirement, you determine the following. The services in scope are included in the Google Cloud Data Residency terms. Business data remains within specific locations under the same organization. Folder structure can contain multiple data residency locations. You plan to use the Resource Location Restriction Organization Policy constraint. At which level in the resource hierarchy should you set the constraint? The options are: Option A, Folder. Option B, Resource. Option C, Project. Option D, Organization.
To arrive at the correct answer, we focus on the keywords. Business data must be stored in specific locations. Folder structure can contain multiple data residency locations. Resource location restriction organization policy constraint. Level in the resource hierarchy.
The correct answer is option C, Project.
Why is this correct? C. Since the folder structure can contain multiple data residency locations, applying the constraint at the project level allows individual projects within the same folder to be restricted to different specific locations as required. Why are the others incorrect? A. Applying the constraint at the folder level would restrict all underlying projects to a single location, violating the condition that the folder structure can contain multiple data residency locations. B. Organization policy constraints, including resource location restriction, cannot be applied directly at the individual resource level. They must be applied at the organization, folder, or project level. D. Applying the constraint at the organization level would enforce a single location globally, which contradicts the company's global expansion plans and the need for multiple locations.
A customer is running an analytics workload on Google Cloud Platform, GCP, where compute engine instances are accessing data stored on cloud storage. Your team wants to make sure that this workload will not be able to access, or be accessed from, the Internet. Which 2 strategies should your team use to meet these requirements? Choose 2. The options are: Option A, configure private Google access on the compute engine subnet. Option B, avoid assigning public IP addresses to the compute engine cluster. Option C, make sure that the compute engine cluster is running on a separate subnet. Option D, turn off IP forwarding on the compute engine instances in the cluster. Option E, configure a Cloud NAT gateway.
To arrive at the correct answer, we focus on the keywords. Compute engine instances are accessing data stored on cloud storage, not be able to access, or be accessed from, the Internet.
correct answers are option A, configure private Google access on the compute engine subnet, and option B, avoid assigning public IP addresses to the compute engine cluster.
Why is this correct? A. Private Google access enables VMs to reach Google APIs like cloud storage using internal IP addresses, avoiding the need for an external IP or internet access. B. Omitting public IP addresses ensures the compute engine instances have no direct inbound or outbound internet connectivity, satisfying the strict no internet requirement. Why are the others incorrect? C. Placing the cluster in a separate subnet provides network isolation but does not inherently block internet connectivity, as instances in the new subnet could still be assigned public IPs. D. IP forwarding is used when an instance acts as a router to process packets addressed to other destinations. Disabling it does not stop the instance itself from accessing the internet. Why are the others incorrect? E. Cloud NAT specifically provides outbound internet access for instances without external IP addresses, which directly violates the requirement that the workload must not access the internet.
In an effort for your company messaging app to comply with FIPS 140-2, a decision was made to use GCP Compute and Network Services. The messaging app architecture includes a managed instance group, MIG, that controls a cluster of compute engine instances. The instances use local SSDs for data caching and UDP for instance-to-instance communications. The app development team is willing to make any changes necessary to comply with the standard. Which options should you recommend to meet the requirements? The options are: Option A, encrypt all cache storage and VM-to-VM communication using the Boring Crypto module. Option B, set disk encryption on the instance template used by the MIG to customer-managed key and use Boring SSL for all data transit between instances. Option C, change the app instance-to-instance communications from UDP to TCP and enable Boring SSL on clients' TLS connections. Option D, set disk encryption on the instance template used by the MIG to Google Managed Key and use Boring SSL library on all instance-to-instance communications.
To arrive at the correct answer, we focus on the keywords: comply with FIPS 140-2, local SSDs for data caching, UDP for instance-to-instance communications.
The correct answer is option A, encrypt all cache storage and VM-to-VM communication using the Boring Crypto module.
Why is this correct? A. The Boring Crypto module is FIPS 140-2 validated. Using it to encrypt both the local SSD cache storage and the UDP instance-to-instance communications ensures that all data at rest and in transit meets the required compliance standard. Why are the others incorrect? B. Customer-managed encryption keys, CMEK, cannot be used with local SSDs, which only support Google-managed keys. Additionally, Boring SSL is designed for TLS, TCP, and does not natively support UDP communication. C. Changing the architecture from UDP to TCP is unnecessary when Boring Crypto can be used directly for UDP. This option also completely fails to address the FIPS compliance requirement for the data cached on local SSDs. D. While Google Managed Keys automatically encrypt local SSDs, Boring SSL is an implementation of SSL/TLS that operates over TCP and does not support the application's UDP instance-to-instance communication without significant changes.
Your organization relies heavily on Cloud Run for its containerized applications. You utilize Cloud Build for image creation, Artifact Registry for image storage, and Cloud Run for deployment. You must ensure that containers with vulnerabilities rated above a Common Vulnerability Scoring System (CVSS) score of medium are not deployed to production. What should you do? The options are: Option A, implement vulnerability scanning as part of the Cloud Build process. If any medium or higher vulnerabilities are detected, manually rebuild the image with updated components. Option B, perform manual vulnerability checks post-build, but before Cloud Run deployment. Implement a manual security engineer-driven remediation process. Option C, configure binary authorization on Cloud Run to enforce image signatures. Create policies to allow deployment only for images passing a defined vulnerability threshold. Option D. Utilize a vulnerability scanner during the cloud build stage and set artifact registry permissions to block images containing vulnerabilities above medium.
To arrive at the correct answer, we focus on the keywords Cloud Run, Cloud Build, Artifact Registry. Ensure that containers with vulnerabilities rated above a Common Vulnerability Scoring System (CVSS) score of medium are not deployed.
Correct answer is option C. Configure binary authorization on Cloud Run to enforce image signatures. Create policies to allow deployment only for images passing a defined vulnerability threshold.
Why is this correct? C. Binary authorization integrates natively with Cloud Run to enforce deployment policies. By requiring attestations based on vulnerability scan results, it automatically blocks the deployment of images that exceed the acceptable CVSS threshold. Why are the others incorrect? A. This relies entirely on manual intervention instead of automated policy enforcement. It is inefficient, error-prone, and does not programmatically prevent a vulnerable image from being deployed. B. Manual checks before deployment are not scalable and fail to provide an automated, systemic control to guarantee that vulnerable containers cannot reach production. D. Artifact Registry IAM permissions control access to the registry itself, but they cannot natively evaluate image contents to block storage or deployment based on vulnerability scan results.
Your organization uses BigQuery to process highly sensitive, structured datasets. Following the need-to-know principle, you need to create the Identity and Access Management (IAM) designed to meet the needs of these users. Business user must access curated reports. Data engineer must administrate the data lifecycle in the platform. Security operator must review user activity on the data platform. What should you do? The options are: Option A. Configure data access log for BigQuery services and grant project viewer role to security operator. Option B. Set row-based access control based on the region column and filter the record from the United States for data engineers. Option C. Create curated tables in a separate dataset and assign the role roles/BigQuery.DataViewer. Option D. Generate a CSV data file based on the business user's needs and send the data to their email addresses.
To arrive at the correct answer, we focus on the keywords highly sensitive, structured datasets, need-to-know principle, curated reports.
The correct answer is option C. Create curated tables in a separate dataset and assign the role roles/BigQuery.DataViewer.
Why is this correct? C. To enforce the need-to-know principle for business users, isolating curated data into a separate BigQuery dataset and granting the precise roles/BigQuery.DataViewer permission ensures they only access the specific reports they require. Why are the others incorrect? A. Granting the broad project viewer role violates the principle of least privilege. Security operators should only be granted specific logging permissions, e.g., roles/logging.viewer, to review activity, not read access to all project resources. B. Applying row-based geographical filters for data engineers is illogical based on the requirements. Data engineers require administrative roles, like data owner, to manage the data lifecycle, not restricted regional data views. D. Emailing highly sensitive data as CSV files is a severe security violation. It entirely bypasses IAM, eliminates access auditing, and drastically increases the risk of data exfiltration.
Refer to the attached Picture 1, reference exhibit. You have the following resource hierarchy. There is an organization policy at each node in the hierarchy as shown. Which load balancer types are denied in VPCA? The options are: Option A, all load balancer types are denied in accordance with the Global Nodes policy. Option B, internal_TCP_UDP, internal_HTTP_HTTPS is denied in accordance with the folders policy. Option C, external_TCP_proxy, external_SSL_proxy are denied in accordance with the project's policy. Option D, external_TCP_proxy, external_SSL_proxy, internal_TCP_UDP, and internal_HTTP_HTTPS are denied in accordance with the folder and project's policies.
To arrive at the correct answer, we focus on the keywords: resource hierarchy, organization policy, load balancer types, denied, VPCA.
The correct answer is option A. All load balancer types are denied in accordance with the global nodes policy.
Why is this correct? A. The organization node enforces a global all values, deny policy. Because the folder and project nodes only specify denied values without explicitly allowing any types, they do not override the parent's total denial. Consequently, all load balancer types remain denied in VPCA. Why are the others incorrect? B. This incorrectly isolates the folder's policy, failing to account for the organization node's overarching all values, deny constraint which globally denies all load balancer types. C. This incorrectly focuses solely on the project-level policy, ignoring the all values, deny constraint enforced at the root organization node. D. This merges only the folder and project policies, overlooking the organization node's all values, deny constraint which enforces a comprehensive denial of all load balancer types.
Your team needs to make sure that their backend database can only be accessed by the front-end application and no other instances on the network. How should your team design this network? The options are: Option A, create an ingress firewall rule to allow access only from the application to the database using firewall tags. Option B, create a different subnet for the front-end application and database to ensure network isolation. Option C, create two VPC networks and connect the two networks using Cloud VPN gateways to ensure network isolation. Option D, create two VPC networks and connect the two networks using VPC peering to ensure network isolation.
To arrive at the correct answer, we focus on the keywords: backend database, only be accessed by the front-end application, no other instances on the network.
The correct answer is option A. Create an ingress firewall rule to allow access only from the application to the database using firewall tags.
Why is this correct? A. Ingress firewall rules in GCP using target and source tags, or service accounts, provide granular microsegmentation, allowing access to the database exclusively from the front-end application while blocking all other instances. Why are the others incorrect? B. Subnets in GCP do not act as security boundaries. Instances in different subnets within the same VPC can communicate by default, failing to provide the required network isolation. C. Connecting two VPCs via Cloud VPN introduces unnecessary complexity and latency. It does not provide the granular instance-to-instance access control required without also relying on firewall rules. D. VPC peering connects separate networks but does not inherently enforce strict access controls. Firewall rules would still be required to restrict access specifically between the front-end application and the database.
A website design company recently migrated all customer sites to App Engine. Some sites are still in progress and should only be visible to customers and company employees from any location. Which solution will restrict access to the in-progress sites? The options are: Option A, upload an .access file containing the customer and employee user accounts to App Engine. Option B, create an App Engine firewall rule that allows access from the customer and employee networks and denies all other traffic. Option C, enable Cloud Identity Aware Proxy, IAP, and allow access to a Google group that contains the customer and employee user accounts. Option D, use Cloud VPN to create a VPN connection between the relevant on-premises networks and the company's GCP Virtual Private Cloud, VPC, network.
To arrive at the correct answer, we focus on the keywords: App Engine, only be visible to customers and company employees from any location.
The correct answer is option C. Enable Cloud Identity Aware Proxy, IAP, and allow access to a Google group that contains the customer and employee user accounts.
Why is this correct? C. Cloud IAP provides zero-trust access control for App Engine applications based on user identity, not IP address. This enables secure access for specific users, customers and employees in a Google group, regardless of their location. Why are the others incorrect? A. App Engine does not use .taxs files for access control, as they are specific to Apache web servers. It is not a supported method for restricting access. B. App Engine firewall rules restrict access based on IP address ranges. Since users need access from any location, their IPs are dynamic, making firewall rules ineffective. D. Cloud VPN connects on-premises networks to Google Cloud VPCs. It does not secure App Engine public endpoints or allow users to access the application from arbitrary locations.
You are on your company's development team. You noticed that your web application hosted in staging on GKE dynamically includes user data in web pages without first properly validating the inputted data. This could allow an attacker to execute gibberish commands and display arbitrary content in a victim user's browser in a production environment. How should you prevent and fix this vulnerability? The options are: Option A, use Cloud IAP based on IP address or end-user device attributes to prevent and fix the vulnerability. Option B, set up an HTTPS load balancer, and then use Cloud Armor for the production environment to prevent the potential XSS attack. Option C, use Web Security Scanner to validate the usage of an outdated library in the code, and then use a secured version of the included library. Option D, use Web Security Scanner in staging to simulate an XSS injection attack, and then use a templating system that supports contextual auto-escaping.
To arrive at the correct answer, we focus on the keywords. Dynamically includes user data in web pages without first properly validating the inputted data, execute gibberish commands and display arbitrary content in a victim user's browser, prevent and fix this vulnerability.
The correct answer is option D, use Web Security Scanner in staging to simulate an XSS injection attack, and then use a templating system that supports contextual auto-escaping.
Why is this correct? D. Web Security Scanner identifies XSS vulnerabilities in GCP applications. Using a templating system that supports contextual auto-escaping is the developer best practice to fix XSS by sanitizing untrusted user inputs before they are rendered in the victim's browser. Why are the others incorrect? A. Cloud IAP controls access based on identity and context, but does not sanitize inputs or fix the underlying XSS vulnerability in the application code. B. Cloud Armor provides edge filtering, WAF, which can help block some XSS attacks, but it does not fix the underlying vulnerability within the application code, which requires developer remediation. C. The scenario describes an XSS vulnerability caused by unvalidated user input, not an outdated library. Scanning for and updating outdated libraries will not address the application's input validation flaw.
A customer's company has multiple business units. Each business unit operates independently, and each has their own engineering group. Your team wants visibility into all projects created within the company and wants to organize their Google Cloud Platform, GCP, projects based on different business units. Each business unit also requires separate sets of IAM permissions. Which strategy should you use to meet these needs? The options are: Option A, create an organization node and assign folders for each business unit. Option B, establish standalone projects for each business unit using gmail.com accounts. Option C, assign GCP resources in a project with a label identifying which business unit owns the resource. Option D, assign GCP resources in a VPC for each business unit to separate network access.
To arrive at the correct answer, we focus on the keywords: multiple business units, visibility into all projects, organize their Google Cloud Platform, GCP, projects based on different business units, separate sets of IAM permissions.
The correct answer is option A, create an organization node, and assign folders for each business unit.
Why is this correct? A. The organization node provides central visibility and control over all GCP projects. Folders allow you to organize projects by business unit and apply separate sets of IAM policies at the folder level, cascading down to the respective projects. Why are the others incorrect? B. Standalone projects using consumer gmail.com accounts lack a central organization node, preventing company-wide visibility, centralized billing, and structured hierarchical IAM management. C. Placing all resources in a single project limits IAM separation. While labels help with billing and filtering, a single project cannot effectively isolate independent engineering groups requiring separate IAM permissions. D. VPCs only isolate network traffic. They do not provide the project-level organization or hierarchical IAM permission management required for independent business units.
You are deploying regulated workloads on Google Cloud. The regulation has data residency and data access requirements. It also requires that support is provided from the same geographical location as where the data resides. What should you do? The options are: Option A, enable access transparency logging. Option B, deploy assured workloads. Option C, deploy resources only to regions permitted by data residency requirements. Option D, use data access logging and access transparency logging to confirm that no users are accessing data from another region.
To arrive at the correct answer, we focus on the keywords: regulated workloads, data residency, and data access requirements. Support is provided from the same geographical location.
The correct answer is option B, deploy assured workloads.
Why is this correct? B. Assured workloads is specifically designed to enforce data residency, apply access controls, and ensure that Google support personnel are restricted to specific geographical locations to meet strict regulatory compliance. Why are the others incorrect? A. Access transparency logging provides visibility into Google Cloud support actions but does not proactively enforce data residency or restrict the location of support personnel. C. Manually deploying resources to specific regions only addresses data residency. It does not enforce data access controls or guarantee the geographic location of Google Cloud support personnel. D. Logging only provides reactive visibility and detective controls. It does not proactively enforce data residency, restrict data access, or limit support personnel to a specific geographic location.
You are responsible for protecting highly sensitive data in BigQuery. Your operations teams need access to this data, but given privacy regulations, you want to ensure that they cannot read the sensitive fields such as email addresses and first names. These specific sensitive fields should only be available on a need-to-know basis to the human resources team. What should you do? The options are: Option A, perform data masking with the Cloud Data Loss Prevention API, and store the data in BigQuery for later use. Option B, perform data redaction with the Cloud Data Loss Prevention API, and store the data in BigQuery for later use. Option C, perform data inspection with the Cloud Data Loss Prevention API, and store the data in BigQuery for later use. Option D, perform tokenization for pseudonymization with the Cloud Data Loss Prevention API, and store the data in BigQuery for later use.
To arrive at the correct answer, we focus on the keywords: highly sensitive data in BigQuery, cannot read the sensitive fields, only be available on a need-to-know basis.
The correct answer is option D, perform tokenization for pseudonymization with the Cloud Data Loss Prevention API, and store that data in BigQuery for later use.
Why is this correct? D. Tokenization, pseudonymization, replaces sensitive data with tokens. This protects the data from the operations team while allowing authorized HR personnel to detokenize and access the original data on a need-to-know basis. Why are the others incorrect? A. Data masking partially obscures data and is typically irreversible. meaning the HR team would be unable to access the full, original sensitive fields. B. Data redaction completely removes the sensitive data irreversibly, making it impossible for the HR team to access the original information when needed. C. Data inspection identifies and classifies sensitive information but does not protect or alter it to prevent unauthorized access by the operations team.